Okay, good afternoon or evening. Um, Said we were going to go over the questions from the homework from the other day. The first thing I gotta do is apologize actually, because I thought I had saved a copy that I could take home with me, but I didn't. So we can't go over all of them because I don't remember all the numbers uh, by heart, but I remember some of it. So we can knock out actually the back page here. All right, so let's give this a try. All right, so one of our questions was Mario, who had a 24 pack of water, and each bottle was holding 1.5 liters. And we want to know how many gallons of water Mario have. And the actual problem had like more information on like how much it costs, but it doesn't matter because all we care about is this number of gallons. Okay, so first thing we got to figure out is, since it says each bottle is 1.5 liters, we want to know how many liters of water does Mario have. Okay, so if we think about what operation we can do to figure out the number of total liters. So if we think, if one bottle is 1.5 liters, to get the total, that's the key word there. Anytime we're finding total, we have a multiple of something, and multiple, there's another helpful word there, is we're going to have to multiply. So I know 24 times 1.5. So that's our first piece of math we have to do. So 24 times 1.5. Okay. Remember, when you're multiplying decimals, you don't have to line up the decimal points, and we're going to see what happens to them at the very end. So 5 times 4 is 20, and 5 times 2 is 10, plus 2 more is 12. Before we go to the second number, we always bring down a 0, and then we multiply 24 times 1 is just 24. And then we can get our answer here. So we're going to have 360. And then we check, where does our decimal need to go? So we look at how many decimal places were in our two factors. So there were 0 up top, so that was just a whole number, and 1 decimal place in our second. So that is a total of 1 decimal places that we need in our answer. So we're actually going to have 36.0, or just 36 liters of water, right? So we're halfway there, except we don't really care how many liters there are. We want to know what that is in gallons. And I don't remember what the conversion rate it gave on the paper, so we went with the actual, like the for real, that 1 liter is equal to 0.264172 United States gallons. And let's round this off. How many decimal places? Let's say 4 or 3. Just because after that, it's not going to change your answer by a whole lot. Because I think it said round to the nearest gallon. And 4 decimal places is not going to really change the total gallons. At least not when there's only 36 of them. Alright, so we have, if 1 liter is this much, we want to know how much would be in 36 liters. So it's the same kind of thing we did up here. This is, again, we want to know the total number of gallons, so it's multiplying. So we're going to take the number of liters, and we're going to multiply that, and let's put this one actually up top here, by the amount of gallons per liter. And we're going to talk a lot more about rates next week, which might be this week, depending on when you see this. It's September the 17th-ish. Alright? Why I put this number up top? Generally speaking, to make things simpler on yourselves, you want to put whichever number has the most digits up top. So in this case, 3 on top, 2 on the bottom. So it's just going to be a little bit simpler to multiply like this. Okay, so let's do this. 6 times 4 is 24. 6 times 6, 36, plus 2 more is 38. 6 times 2 is 12, plus 3 is 15. Alright, that's good. And let's pick purple. Before we go to our second number, we bring down a 0. 3 times 4 is 12. Actually, we can get rid of these now. That doesn't confuse us. So 3 times 4 is 12. Carry the 1. 3 times 6, 18, plus 1 more, 19. And 3 times 2 plus 1 is 7. Okay. We add these up. We get 4, 10, 15, and 9. Okay. So then again, it comes down to how many decimal places do we need? So we look. We have 1, 2, 3 up top, and we have nothing again in the bottom. So 3 plus 0 means we need 3 decimal places in our answer. We get 1, 2, 3. So Mario has 9.504 gallons, which we could round up depending on how the question asks. If we just care that this is a number, we can say, since this is 5 or more, this would round up. We could say this is 10 gallons. But if the question asks something like, how many full gallon jugs could Mario fill? Could he fill up 10? No, because he doesn't have enough for that. So depending on how the question asks you, it might be 10 gallons or it might actually be 9 gallons. And so you have to use your critical thinking skills and determine what is the question asking for, and that'll tell you which way you need to round. Okay? And if you didn't believe the answer, we can actually use our Google converter to help us out here, and it says that 36 liters is 9.51019. So by using those extra decimal places, that we see it changes by what? 510 from 504. So it changes by 100th, really half of 100th of a gallon, which is insignificant for our purposes. Okay? So there's a basic idea for this question. And I like this answer best. Alright, the second one, which is actually the last one, which is not this one. It's this one. It's about John making a fence. I think it was for his dog. So let's give him a dog. Dog. Ooh, some of these dogs are terrible. Okay. There's his dog. Okay, that's kind of weird. Alright. So he wants to build a house for his dog because you wouldn't want this running around your neighborhood. Okay. And I think these were the numbers it gave us for his two options. If not, I'm sorry. But we're going to go over the basic idea of how this problem will work. Because if you remember, and hopefully you remember, hopefully you have the paper unlike me, is that the 3 last problems all had the same kind of idea. Okay, so we're going to look at the logic. And so after explaining this one, you should be able to go back and say, oh, those other problems they're like exactly the same as this. So let's look at our first option. He has 16 posts in the shape of a square. So the very first thing I would think about there is, okay, the posts are just like a single point, right? And they're connected by like fencing, yeah, something like that, right? And then the next post, and so on. So if we want to figure out how to lay these out in a square, we would have to start with the corners. So we know he's building a square, so he's going to have 4 corners, and they should all be the same distance from each other, right? Because that's a square. 4-sided shape, all sides the same. So that takes up 4 of our posts, which means we still need to place 16 minus 4. We still need 12 to go. And then we can use some simple math. We have 12 posts and 4 sides we need to fill up. So 12 divided by 4 is 3, which means in between each corner post we need to have 1, 2, 3 posts. And it's going to be like that on every single side. 1, 2, 3, 1, 2, 3. So if you count these, you'll get 16, and you'll be like, hooray, I've made a square. Okay? And now what we're going to do, because I don't care about this number, honestly. At this point, I don't really care. So I'm just going to say each of these posts is connected. Instead of saying 4 feet 6 inches, that's going to be some decimals, and we can look at that later. Let's just say this is 1 foot. Okay? 1 foot. In between each post, 1 foot. So that means we have 1, 2, 3, 4 sections of fencing that are each 1 foot long, which means our total length is going to be 4 feet. Okay? Which means this side over here, since it's a square, has to be 4 feet. And the same down here and over here. So to find the area of a square is just the same as finding the area of a rectangle, which is just length times width, which is 4 times 4, which is 16. And we're going to look as to why this number doesn't really matter, because we're going to focus on which of these options is bigger for right now, and then we'll worry about the question of how much bigger is it, because that's not nearly as much fun to figure out. So our second option, he only has 14 posts this time, but he gets to use his house as one of the walls. So you think of it, he's got his house, and he's going to build his doghouse right next to it. So we're going to call his house this line right here. Okay, and you can imagine the rest of the house is around like this. Okay, so here's one side, which means if we're building our rectangle, or our square, I don't know if this one said it was a square, but we're going to make a square anyway because we're going to see how that works. We already have 2 of our corners, and they're already made by the house, so we don't even need those as points. So the only corners we need are this one and this one, which means we still have 12 more posts to use. And let's put 12 here. Okay? But now if we think about it, we don't have to construct 4 sides of fencing here. We only have this one, this bottom one, and this one on the right. So we just have to take this 12 and divide it into 3 sections, because our last section is built because it's the house. So 12 divided by 3 is 4, which means on each side here we can put in 1, 2, 3, 4 posts. So 1, 2, and this isn't the best drawn to scale thing I've ever done in my life, but oh, it's okay. 2, 3, 4. Okay. And now we can do the same thing we did. The distance between the posts is the same no matter what, so this is still going to be 1 foot, 1 foot, 1 foot, 1 foot, and 1 foot. But if we count these up, we notice that the side, if we add all these up, is actually now going to be 5 feet. And it's actually going to work out the same down here. So this is going to be 5 feet as well. And since it's a square, that has to be true about our remaining 2 sides. So to find our area, we're going to have area's length times width, which is 5 times 5. And that's going to be 25. Ooh, I should put units on me so I don't get in trouble. So that's 25 feet squared, which we can see is bigger than 16 feet squared. So if we say which option is bigger, it's got to be this one. Alright. So now we can go back and do the less fun part of this. This is the fun part. We got to draw pictures and see dogs that look all evil. Evil eyes here. So what if we actually wanted to use 4 feet 6 inches? So let's erase some of this. Our drawing is not going to change. The way it's constructed stays the same. The only thing that's going to change are the actual side lengths. Okay, so 4 feet 6 inches. I think the answer is in feet, so let's go with feet. So we have to think, what part of a foot is 6 inches? I think I have a, in case you forgot what a ruler looks like, I think I've got one of them here. Imperial, no, it's not big enough. Yes, okay. So here is our ruler, And 1 foot we know, hopefully, is 12. Oh, I can't write on it. It's 12 inches. But what we have is 6 inches. So what part of a foot is that? Well, 6 out of 12, we could write that as a fraction. That's simply 6 over 12. And then we can simplify this. And I hope some of us know this already. This should have been something you did in 5th or 6th grade. 6 out of 12 is the same as 1 over 2. So really we're saying it's 4.5 feet apart. And then hopefully we also remember that 1/2 as a decimal is 0.5. And if you don't know that, you can use TIBO, top in, bottom out. And we get that exact same answer. Right? So this is really, it's 4 feet and 1/2 a feet, or 1/2 of a foot to be grammatically correct. So really we're saying it's 4.5 feet apart. And all we've done is we've just changed, how do we write 4 feet 6 inches as just feet? It's very difficult to do math with 4 feet 6 inches, right? Okay, so now let's look at what we have to do now. So each of these little purple lines, instead of being 1 foot, which was easy and nice and fun, now each of them is 4.5 feet, which means it's 4.5 plus 4.5 plus 4.5 plus 4.5, or simply, since there's 4 of them, it's going to be times 4. Okay? Okay, hopefully that makes sense. If not, rewind it back, just pause it, and think about our picture. Think about what we did before. Alright, we're going to skip some of the multiplying here, because I believe that if you're watching this, you're not the kids I'm worried about your multiplication skills. So this is actually going to come out to 18 feet. And since it's a square, if this side is 18, then this side has to be 18 as well. Which means our area here is going to be 18 by 18, which is 324? Is it 324? Hold on. 18 times 18. Yeah, 324. Okay, 324 square feet. It's a pretty good amount of room to run, I think. And then we come over here to our green fence, which you remember was bigger, which means no matter how much of a number we put here, it's still going to be bigger, assuming we do our math correctly. So we have 1, 2, 3, 4, 5 sections of fencing, so each of these is going to be 4.5 times 5. 4.5 times 5 feet long. So that's going to be 22.5 feet. So it's going to be 22.5 by 22.5. If we multiply that out, that'll give us, one sec, 506.25 feet squared. This should be feet squared too. So we can see it's much bigger. I think one of the questions was, how much bigger is it? In which case we're defining what is the difference between this and this. So we could just subtract them. And at this point I really hope these numbers are the same as what's on the paper, otherwise this will all be sort of for nothing. But the logic will stay the same no matter what the numbers were. So 25 minus 0 is 25. 506 minus 324, we're going to have to borrow here. So 4 and 10 becomes 9 and 6 becomes 16. I can't believe I just did that. That's so wrong. Wait, no, don't be mad at me. 6 minus 4 is 2. Why am I borrowing? That's not smart. Now I can borrow a little bit. So 10 minus 2 is 8. 4 minus 3 is 1. So it's about 182.5 square feet bigger. Alright, so that's the basic idea here. But I said this is a lot like the other two questions. And we're going to take a look at how we can use what we did here to help us with the other ones. And this is a wonderful question. This is a question you see like every year. Maybe not every year. A lot of years. Right? You might have seen it last year when you're doing area of stuff. They'd say, okay, if this is, let's say, I don't know, 7 by 7, and this one, how can we make this add up right? Let's say 10 and 4. Okay, and they'd say, what's the perimeter of this? And so you'd say, I know perimeter. I just add all these up. This isn't on the paper. This is me doing math because math's amazing, right? Okay, so the perimeter of this is 28. And the area of this, length times width, 10 times 4 is 40. Okay, it's 28 and 40. Then we come over here to our squarish looking shape. We know it's a square because same sides all around. We say, what's the perimeter of this? You'd say, well, this is 7 and this is 7. So 7 plus 7, 7 and 7 gives us a perimeter of 28. Okay. And the area will be 7 times 7 is 49. And depending on how quality your math teacher was, they hopefully looked at you and said, what do you notice about this? And then you'd be like, hey, look, the perimeters are exactly the same. So the distance around the outside does not change from here to there. But what does change, in a sort of big way here, is that the area is bigger on this shape over here. Okay? And there's a reason for that. And we can look at it in an even more dramatic example here. If we took another rectangle and we put it like this. Okay? So let's say say this is 13. Oh, I might have made this too big. Hold on. I don't want to confuse you with pictures. Okay. Let's say this is 13 and this is 1. So we have a rectangle that's 13 by 1. So our perimeter, again, 13 over here, 1 over there. If we add these up, 14, 27, 28, look at that. Our perimeter is still 28, right? But what about our area? Our area is 13 times 1. 13 times 1 is just 13. So we notice that our area has gotten even smaller without our perimeter changing. And now you have 3 here, and hopefully you can say, well, as it gets more rectangular, as it gets stretched out more and more, that even as the perimeter stays the same, the area gets smaller and smaller. And so as it gets less stretched out, I don't know what the word for less stretched out is. I'm sure there is one. The area gets bigger until it gets to our perfect rectangle here. The perfect rectangle is a square. Same all the way around. And this will always, 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 if all we're drawing is one shape, that to maximize the area, you always want to build, I don't want to say always. If we're making polygons, don't count this with circles. That's going to mess you up. Okay? And we'll get to that later. But if you're just drawing polygons, squares, rectangles, triangles, you always want to make as close to a perfect square as you can. Okay? So there's your helpful hint for, it was like the marching band. And there's another one about fences. So if it says, how do you make the biggest area? The answer should always be, how can I make this into a square? Okay? So I'm going to leave you with that. We're going to come back Monday, hopefully, and knock out the rest of these. Alright, so have a good weekend. Alright, bye. Oh yeah, don't forget, like, comment, subscribe, and share on your Facebooks and Instagrams and Twitters. Okay, bye.